Hello, this video will introduce you to the cosine law. So we've already learned about the primary trigonometric ratios as well as the sine law. But in some cases, we may have triangles with given information where neither of those is helpful when trying to solve for an unknown value. So here's a triangle ABC, with these given values. And let's say we want to solve for side C. Okay. Now, here we're not going to apply the primary trigonometric ratios because this is not a right triangle. So we look to the sine law. Since we're solving for an unknown side length, I'm going to set up the sine law where the side lengths are in the numerators. So we've got A over sine A equals B over sine B equals C over sine C. And we're going to go through and check off the given information that we have. So we know what side length B is, that's 14 meters. We know what side length A is, that's 16 meters. We know what angle C is, which is 73 degrees. And we're trying to solve for side length C. So this is our unknown that we want to solve for. Now, we don't really have a way to find angle A or angle B because we only have the one angle in the triangle. So if we had two angles, we could solve for the third one by using the sum of the angles inside the triangle are 180 degrees. But since we only have one angle here, there's not an easy way to solve for either angle A or B. And if we look here, we don't have a complete ratio set up for sine law, right? This ratio is incomplete because we don't know angle A. This ratio is incomplete because we don't know angle B. And this ratio is incomplete because we don't know side C, which is what we're trying to solve for. So because there's no complete ratio to set this third ratio equal to, right? Both of these are incomplete. Because there's no other complete ratio to compare this ratio to, we can't possibly use the sine law to solve for side length C. So we need something different, and that's where the cosine law comes in. So for the cosine law, if we have any triangle, let's label it ABC, and the side lengths are labeled opposite the matching angles. So this is side length A, this is side length B, and this is side length C. So for any triangle ABC, we have the following relationship. A squared is equal to B squared plus C squared. Now, this is the relationship that we would know for right triangles, which is the Pythagorean theorem. But cosine law has a little bit of an adaptation to it that makes it valid for all triangles. Minus 2 times B times C times cosine of A. So this angle here, angle A, matches the side that's here. Now we can write this relationship starting with any of the three sides. So this is the cosine law. If we start with side A and start with A squared equals, we can also write the version of cosine law that starts with side length B. So we start with B squared equals, and then we fill in the other two side lengths here. So this would be A squared plus C squared minus 2 times A times C times cosine, and this angle matches the side length at the start, so this is going to be times cosine of B. And we have the version of sine law for the third side in the triangle, which is side C. So we start with C squared equals, and here we fill in the other two sides of the triangle. So this will be A squared plus B squared minus 2AB cosine C. Now, this video won't go through the proof of cosine law, but we may do that later in another video or if we are back in class at some point in time. Okay, so we're going to use these cosine law relationships, which they're really all the same relationships, just depending on which side length or angle we want to solve for, we're going to choose the appropriate one. We're going to use this to solve for some unknown sides and unknown angles in triangles. So we're going to go back to our original question where we're trying to solve for side length C in this triangle. And we've already gone through all of our other options, and they're not going to work for us to solve for side length C. So we've already checked to see if we can use primary trigonometric ratios, and no, because it's not a right triangle. And we can't use Pythagorean theorem here either because this isn't a right triangle. And we've tried to set up sine law, but we didn't have enough information to solve for side length C using sine law either. So cosine law is like our last option. So because we're solving for side length C, we're going to set up the cosine law starting with C squared. So then the other two sides get filled in on the right-hand side. So C squared equals A squared plus B squared minus 2 times A times B times cosine C, because this angle matches this side on the other side of the equation. Okay, then we're going to fill in our known information. So C is what we're solving for, so that's an unknown variable right now, equals side A is 16 meters, so 16 squared. Side B is 14 meters, we have 14 squared. 16 squared plus 14 squared minus, and we fill in side A and B again here. So this is 2 times 16 times 14 times cosine of angle C, which is 73 degrees. Okay. Now, in order to solve for just side C, right now we have C squared equals all of this. So in order to solve for just C, we take the square root of both sides of this equation. So side length C is going to be the square root of all of this. And when you type this in on your calculator, it's possible you may need to put in an extra set of brackets here just to make sure that you're actually taking the square root of that entire expression. And if you type that all into your calculator all at once, you get that C is about, rounding to one decimal place, 17.9 meters. Okay. So we try to put all of this into our calculator as one calculation so that we're not rounding repeatedly. So the only number we want to round is once at the final answer. Otherwise, we're just introducing more and more error every time we round within one question. Okay, here's another question where we're going to solve for an unknown angle. And again, we look at all of our other options first. So this is not a right triangle, so Pythagorean theorem and primary trigonometric ratios are not going to apply. As well, we could set up the sine law to see if we have enough information to solve. But because we don't have one matching angle and side for x, y, or z, we don't have a matching angle and side, we would not have a complete ratio in sine law. And so we won't have enough information using sine law here. So we try cosine law. Because we are trying to solve for angle y, we're going to use the version of cosine law that includes cosine y at the end of it. So if we're using that version of cosine law, then we need y squared to be on the other side of the equation. So then we fill in the other two sides, which is x and z. So we get x squared plus z squared minus 2 times x times z times cosine y. Then we fill in our known information. So side y is 21, side x is 18, and side z is 17. And cosine y, angle y is our unknown, so we're going to leave that as the variable y for right now. So now the process of isolating y is not quite as easy as the process of isolating c from the last example, where c was almost isolated in the equation already. Here, it's going to take a little bit more work to get y isolated. So the first thing we notice is we can subtract 18 squared from both sides of the equation and subtract 17 squared from both sides of the equation. That will get us a little bit closer to isolating for angle y. So if we do that, we have 21 squared minus 18 squared minus 17 squared is equal to negative 2 times 18 times 17 times cosine y. And again, I'm just trying to not do any calculations until that very last step, just to make sure that I'm not rounding multiple times within one question. Okay, next, we still want to work towards isolating cosine y and then eventually isolating y. So to do that next, we're going to divide both sides by -2 times 18 times 17. So if we divide on the right-hand side by that, then all of this will divide with the denominator. So all of -2 times 18 times 17 will divide with the denominator. So we're going to be left with just cosine y on the right-hand side. But whatever calculation we do to the right side of an equation, we want to do the same calculation to the left side. So we're also going to divide the left side by that same expression. So now we have cosine y is equal to 21 squared minus 18 squared minus 17 squared divided by -2 times 18 times 17. And to isolate for angle y, we know that we take the cosine inverse of the other side. And this is the point where we want to put this whole calculation into our calculator. And if we do that, we get that angle y is about 73.7 degrees.